Today's lesson is on negative and zero exponents. Before we dive into the lesson, I kind of want to show you why this works. If you look over to the right, it does say negative exponents, any non-zero number with a negative exponent equals its reciprocal with the opposite exponent, meaning x to the negative n is the same thing as saying 1 over x to the n. So that's not exactly intuitive to think about. So one thing I like to show is math is all about patterns, and this really proves why this works through a pattern. So if you're looking at this, which is 3 to the third, which is the same thing as 27. Okay, math has a pattern. If you do 3 times 3, which is 3 to the second, which is 9, we know this. If you do just 3, which is 3 to the first, which is 3. Notice the pattern as you work your way down. So if I'm looking in this column, I've got 3 to the third, 3 to the second, 3 to the first. Each time I work my way down, I'm taking out a factor of 3. So 27 divided by 3 is going to get me to 9. 9 divided by 3 is going to get me to 3. So if I continue my pattern, 3 to the 0, take that factor of 3 out. Okay, so 3 divided by 3 is 1. That's why any zero exponent is going to equal 1. So let's go to the negative one then. If you continue your pattern, so you're starting up here at 3 to the third, take that factor of 3 out. So divide by 3, you get 9. 3 to the second is that 9, so take that factor of 3 out to get to 3 to the first, so 3, divide by 3. And then you're going to divide by 3 again, 1. 3 divided by 3 is 1. So divide by 3 again, you're going to have 1 divided by 3. 1 divided by 3 is 1 over 3. Okay, so 3 to the negative 1 is the same thing as 1 over 3. So then we're going to say 3 to the negative 2. Okay, well, take the factor of 3 out. So divide that by 3. So if we come up here, 1/3 divided by 3 is the same thing as saying keep the first, change your sign, flip the second over the line. So you have 1/3 times 1/3, which gives you 1/9, which if you're looking at this, it's going to be the same thing as 1 over 3 to the second power, so 3 squared. By root of 3, 3 to the second. So if you have 3 to the negative 2, it's the same thing as 1 over 3 to the second power, which is the same thing as 1 over 9. So that pattern continues. 3 to the negative third is going to be the same thing as 1 over 3 to the third. 3 to the negative fourth is going to be 1 over 3 to the fourth. It's just going to continue taking out that factor of 3, dividing each value, the prior value, by 3 to get to the next subsequent value. So when you come over here then and you take a look at all this, if our property says any non-zero number with a negative exponent equals its reciprocal with the opposite exponent, okay, well, if I have 6 to the negative 2, we always want to have positive exponents. We never want to have to work with negative exponents. This thing is going to be saying the same as, oh, okay, let me make that positive. 1 over 6 squared. So now I created a positive exponent. 1 over 6 squared then becomes 1 over 36. So in the next one, we look at this. This is just like that first lesson that we did when we had 8 to the fourth times 8 to the sixth, if they were positive. You would just say, okay, it's the same thing as saying 8 to the 4 plus 6. We're going to do the same thing. We're going to do 8 to the 4 plus negative 6 this time, though. So that's going to be 8 to the negative 2, which now we have to simplify and say, okay, so that's 1 over 8 squared. These are going to take a couple more steps in order to continuously simplify them. So 1 over 8 squared is the same thing as 1 over 64. Okay, now here we have it written as that division problem. So if we go back to our quotient property, it says that when I'm dividing with the same base, subtract my exponents. So this is the same thing as saying 2 to the 6 minus 8 6 minus 8 is negative 2, so this is 2 to the negative 2, which is then 1 over 2 squared, which if we're going to simplify yet again, it's going to be 1 over 4. So when you have a negative exponent, it's the same thing as its reciprocal with that opposite exponent, so it's going to be positive. All right, so the 0 property we just saw over here, when we were dividing and we took that one factor of 3 out, we went from the 3 here, okay, 3 to the first to 3 to the 0, we took that factor of 3 out, we were left with the number 1 because 3 divided by 3 is 1. Not what I wanted to push. So the 0 power property states any non-zero number with 0 exponent equals 1. We saw that pattern, that's why I did it. So 12 to the 0 is going to be 1. Negative 3 to the 0 is going to be 1. But 0 to the 0 power right here says that it's undefined. Okay? Think about this for a second. If you want, pause the video because I'm going to do a spoiler alert. It's going to be undefined because if you think about like 0 to the first power is 0, but then 0 to the 0 power, how can I divide a factor of 0 out? Anything to the 0 power is considered 1. How can I divide that factor of 0 out and create something? I can't create something. It's that wonky rule of any value divided by 0 is going to be undefined because I can't create something out of nothing. So 0 to the 0 power is always considered undefined. So the takeaway from today's lesson is anything to that negative exponent, to make it positive, you just simply put it as its reciprocal and put it in that denominator. So like 8 to the negative 2 is 1 over 8 squared. 2 to the negative 2 is 1 over 2 squared. 6 to the negative 2 is 1 over 6 squared. The other takeaway is anything to the 0 power is 1 except that lovely number 0, which that will be undefined.